points A and B are negative 8, 8 and 4, 0 respectively. Find the equation of the line AB. So the first thing I'd probably want is the gradient. So the difference in the y's, 8 take away 0 and negative 8 take away 4. So that's going to be 8 over negative 12, which is negative 2/3. And now I can use y minus y1 equals mx minus x1, and it doesn't matter which one of these I use as the point. I'm going to use 4, 0 actually. So I've got y take away 0 is negative 2/3, x take away 4. So multiply right through by 3, and I got 3y equals negative 2x plus 8. So that gives me 3y plus 2x is equal to 8. So now we want to calculate the length of AB. So A is here at negative 8, 8. And B is here at 4, 0. We want the length of that. So this is 8, and negative 8 across to 4 is 12. So we just want the square root of 8 squared plus 12 squared. So square root 8 squared add 12 squared is 4 root 13, which is approximately 14.4 units. So now we're given some additional information. C is the point 0, 7, and D is the midpoint of AB. So remember, this one is A, this one's B down here. D is the midpoint of AB, so D is the midpoint here. So that's going to be negative 8 add 4 divided by 2. And 8 plus 0 divided by 2. So that's going to be negative 2 and 4. So that's D. And C we know is 0, 7. And we want to show that ADC is a right angle. So the gradient of AD is going to be, so let's remember A is negative 8, 8. So difference in the y's, we're going to have 8 take away 4, and then we'll have negative 8 take away negative 2. So that's going to be 4 over negative 6, or if we like, negative 2/3. And then we'll do the gradient of DC. So that's using these 2 points here. So we'll have 7 take away 4 divided by 0 take away negative 2, which is 3 over 2. And then if I do MAD multiplied by MDC, that gives me negative 2/3 times 3 over 2, which is negative 1. And that does it because when we multiply the gradients of perpendicular lines, we get negative 1. So the point E now is such that AE is equal to 4, negative 7. So to go from A to E, we go across 4. So we know that A is at negative 8, 8. To go to E, we'll go 4 this way and 7 this way. which will take me to -4, 1. So the position vector of E is going to be -4, 1. And we want to show now that ACBE is a parallelogram. So A is -8, 8. C was 0, 7. So what else have we got? ACB. If I can remember what B is. B is 4, 0. And E is, as we know, -4, 1. Now, there's only 2 marks here, so I'm sure we can use some information from further up the page in order to do this. So we have A, C, B, E like this. So A, C, B, E. And we know that this AE is 4, -7. Now what about CB? So CB is going to be B, take away C, so that's equal to 4, -7. So this is 4, -7. So we've certainly got these sides being the same length and parallel. So we know that these are parallel. So what about AC? So that's going to be C, take away A. So AC is going to be 8, -1. So that's 8, -1. And EB is going to be B, take away E, which is -4, 1. And that also is 8, -1. So this one is 8, -1. And so these sides are parallel. And so we have a second pair of sides which are parallel and equal in length. And therefore, this is a parallelogram.